I was invited to do a field demonstration in the Bay Area, California, 2 years ago, and the president of the local club had an apiary of about 30 colonies that she had gotten mainly from cutouts, and we had a whole group of 25 people there. And after spending the afternoon and inspection the colony, I said, "Do you guys realize how lucky you are? You just had a field demonstration where you got to see every disease known to beekeepers in one apiary, and you've all learned how to recognize American foul brood by smell simply by walking in front of the hives." Wow. I said, "And by the way, how many of you have apiaries within flight distance of this yard?" Most of the hands went up. President of the club. Foul brood, and here's what's a scary thing. As I was going through there's one hive, and I pick out a frame, and you saw the pictures of the very worst foul brood frames that you saw there. I pulled one out and go, "Oh my God, this is textbook, the worst you could possibly see." I stood it up, and as a joke, I said, "So who can tell me what's wrong with this hive?" As a joke, and nobody in the whole club recognized a symptom that is an experienced beekeeper can see from 100 yards away. That's a foul brood frame. Nobody even recognized it. That's really, really scary. So American foul brood, I have, in my experience, dealt with some very serious issues with American foul broods where I had to burn dozens and dozens of colonies. You do not want to let American foul brood spread. It's really highly contagious. Really stay on top of American foul brood. Second thing, there's a question on using antibiotics to treat European foul brood. So far, we've had very good luck still with the Oxytet, it used to be terramycin, for European foul brood. And the trick for using any antibiotic is you want to do a full 12-day continual treatment. So if you use the dry powder, Oxytet is susceptible. First, Oxytet is a totally natural antibiotic. It's found in nature. There's nothing artificial about it at all. It degrades relatively rapidly in the environment. It degrades very rapidly if there's moisture. So if you put it in a hive, the moisture causes it to degrade pretty quickly. So you have to repeat the treatment if you're putting in the dry powder. So typically you go in every 4 to 5 days and you do another sprinkling of it for 3 sprinklings of that. The way beekeepers got around this was we used to use all kinds of methods, wrapping in wax paper for extended release to keep the moisture away from it. And then somebody invented the Crisco extender patty, where you take vegetable shortening and sugar and you mix in your terramycin powder, stir them all up and make a patty and put it in the hive. And what that patty does is it protects the terramycin, the Oxytet, from the moisture in the hive. And then as the bees gnaw away at it to remove this patty and they ingest the sugar, they would get dosed with that. It was a beautiful invention, worked really wonderful, but of course beekeepers always are the worst. They shoot themselves in the foot. So some beekeepers said, "Wow, if that's good, let's just keep it in the hive all the time." Well, that's the surest way to breed for antibiotic-resistant bacteria. With any kind of treatment you put in a hive, you want to put a treatment in and then stop it when you're done, so you're not selecting for resistant pathogens or parasites, whatever it is. So and the extended patty is very good for treating for European foul brood. But the problem is it doesn't give you initial treatment. So if you want to get treated right away, putting the extender patty in, the bees may not gnaw on it at all for a couple of days. You don't get a start. So what we have found that works very, very well is we use the dry powder, a mixture of the sugar and the terramycin, and an extender patty. And you look at what your total dose should be, and you divide that into 3. And you put 1/3 of the dose in as the powder, and on the same day you put in 2/3 of the dose in the extender patty. That way the bees get an immediate shot of the antibiotic because they eat the powder up immediately, and then as they find the patty and start gnawing on it, then that extends the dose out for the 2 weeks. We've had extremely good luck with that with European foul brood. We don't treat prophylactically. I gave that up many, many years ago, but we do treat if we the symptoms, colonies that are symptomatic, or if we do find American foul brood in a yard, we locate that hive. Most of the hives with American foul brood I detect by smell rather than by visual. And then we look at that hive, and then we inspect every other hive in the yard. And if we think there's even any remotest chance that there was drifting of bees or any kind of robbing, then we treat the rest of the hives in that yard and keep an eye on that, on those hives. I've also done experiments where when I've located, we had a truck wreck. I rolled a truck of bees on the freeway some years ago. Luckily, I walked away from it without injury, but lost a load of bees. But then the Caltrans said, oh, you got to get all this cleaned up because, or they would charge me for the cleanup. So we loaded up all the broken combs back on a truck, took them home, not realizing that there was a hive with foul brood in there. The truck got robbed out, and we spent the next 3 years getting foul brood out of our operation, burning dozens and dozens of hives. So I had a time to do lots of experimentation with American foul brood during that period of time. One of the things I did is when we would find a colony, a healthy colony with one single cell of American foul brood, I said, wow, I wonder what would happen would they just clear it up? You know, do I really have to burn the whole colony? So I experimented with a number of colonies, marking them and following them, and the answer is no, it does not clean up. It is not worth it. You find a single cell of American foul brood in a colony, my policy is just burn. We have zero tolerance for it. What we found is it's way cheaper burning and getting rid of it than treating with antibiotics, with ignoring it, anything else. The cheapest thing to do is to get all the equipment gone as fast as you can. And as I guess Emma said, you don't leave it sitting next to your truck for a minute. When we have people coming over to pick up nukes, they bring a 10-frame box, and if they have any used frames in them, I demand that all the boxes are sealed before they come into my bee yard. I don't want any robbing to happen. We are meticulous about not allowing any kind of foul brood coming into the operation. Okay, parasite management. I'm going to focus on only two of the parasites, Nosema ceranae and then Varroa. Varroa will be the emphasis right here. First, let's look at the rules of beekeeping. Now, you'll notice if you go to read any kind of bee literature, go on the internet, beekeepers love to give you rules that you have to follow, or you are a plague on the planet, or you should be demonized, or all that. Instead of giving the rules from the human point of view, I'm going to give you the rules from the bee's point of view. So here's the rules of beekeeping from the bee's point of view. They need a warm, dry cavity. Now, as bee husbandry practitioners, how many of you can provide that? Everybody, no problem. The bees don't give a squat whether it's a Langstroth hive or a Aurora hive or a top bar hive or a pink painted hive or whatever you want. They just need a dry cavity, okay? As far as they're concerned, they still are living in a hollow tree. They don't recognize that they're living in a man-made hive. Rule number 2, they need food. Food is flowers. They need pollen and nectar. From the point of bee husbandry, if they don't have enough nectar coming in, you can give them sugar syrup. If they don't have enough pollen coming in, you can supplement it with pollen sub, a protein supplement. Is there everybody clear on, can you handle rule number 2? Okay. Rule number 3, they need to manage their parasites. And as Megan said, they have been inundated with a whole slew of new parasites in recent years. And the evolutionary process of them adapting to those parasites takes some time. Right now, they're not doing a very good job with some of the parasites. So in order to practice bee husbandry, that's where you can step in and help them to manage the parasites that they are not managing well. And that's it. That was drone brood.
That was drone, okay.
Yeah. That's it. The bees don't care about anything else. Dry cavity, food, and manage parasites. Anybody else who tells you there's any rule in beekeeping, that's a reflection of their own personal prejudices, has nothing to do with the bees, okay? Enjoy bees any way you want. Be a responsible member of the community and don't spread parasites to other people's colonies. American foul brood, Varroa mite, the viruses associated with them, your responsibility to both nature, to the feral bees, and to the beekeeping community is to manage the parasites that the bees are not doing, managing themselves, or remove that colony. Shake them off in soapy water and get out of beekeeping, because you're then a nuisance to the beekeeping community. Okay? This is very popular when I speak to treatment-free beekeeping groups. Okay, yeah, it used to be much, much easier. But we humans are changing things for everything in nature and for the honeybee quite a bit. So here's what, since I've started keeping bees, chalk brood came in, tracheal mite came in, wiped us out, Varroa came in, wiped us out, deforming virus started to evolve and became much more difficult to deal with. Small hybel coming in, Nosema ceranae unnoticed came in, and finally all these new parasites caught up, and we could see that in the raise of the almond pollination rate. Whereas beekeeping was easy up to this point. I started here, almond pollination paid about $8. By this time, it paid $45, and by this time it paid $155. Simple economics shows you how much more difficult it became to keep bees alive. just due to this insult that we're heaping on them, all these new parasites that they're trying to evolve adaptation to. So first one, Nosema ceranae. If you crush a bee under the microscope, this is what a bee's, quote, hair looks like. They look like feathers. These are some breathing tubes, tracheal tubes, and these are Nosema ceranae spores in the gut tissue, and they just fill the gut. You can see a million, maybe a million, I didn't even count them. You can see more spores you could possibly count in a single field of view of crushing a bee's gut. This is the USDA data I showed last night, how there was very little Nosema coming into the Beltsville lab up until about 2002, when it just suddenly skyrocketed. And this is when Nosema ceranae invaded the United States and changed Nosema management somewhat, but not a whole lot. A lot of people misunderstand. Nosema ceranae is very similar to Nosema apis as far as its effect upon bee colonies. What Nosema does is it shortens, it steals the energy, the ATP, directly from the bee's gut cells. So it doesn't have its own, create its own ATP. So it's stealing energy from the bees, and it's stealing protein from the bee's gut and causing the bee's gut cells to lyse, to break open. So it's rough on their digestion, and it steals energy. It shortens the lives of bees to some extent, suppresses their ability to create jelly to feed the larvae. So it is a problem. There's very few signs, though, for Nosema ceranae. Many people mistakenly think they have Nosema. When they actually check, they find out that they don't. The crawlers, as I mentioned before, out in the mornings, you see them in front of the hives. During the winter, bees with Nosema ceranae, when they get a break to fly, they will fly out and abandon the colony and not come back. So if you pick up some of the bees that are in the snow out here, then a high percentage of them often have Nosema infection. The most common misconception is that dysentery equals Nosema. There was never a relationship between Nosema ceranae and dysentery, and there's absolutely no relationship between, Nosema apis and dysentery. And there's absolutely no relationship between Nosema ceranae and dysentery. Nosema ceranae does not cause dysentery in bees. Dysentery is caused by other things, typically a yeast infection or a high mineral honey or honeydew, especially honeydews cause a lot of dysentery. Complex sugars that the bees are unable to digest, those will cause dysentery. Pollen sub that they're not able to digest well, that will cause dysentery. But it's not due to Nosema. The confusion is that if you do see dysentery in the hive on the outside, that means there's also bees pooping on the inside of the hive. If some of those bees have Nosema, then they will definitely transmit it within the hive. One of the experiments I did, and it's on the website, is we went into hives, and this is something that I was curious about. Megan, wake up a second, because I'm going to talk about you, to you. One of the things on your question of transmission of disease, I did an experiment where we went out to like 24, 36 hives, and every month we'd go in there and we'd crush about 30 to 50 bees on the top bars. And to see whether when you crush a bee and spread its guts and the bees immediately would mob on there and eat that all up, whether it actually causes the transmission of diseases in the hive. And we saw zero effect throughout the entire summer of going in every month and crushing all those bees in the hive. When we saw the effect was during the winter. So when bees are confined during the winter and they get dysentery during the winter, then if they do have some have Nosema, it will definitely spread it throughout the hives. But it's not the Nosema causing the dysentery, it's the dysentery that helps the transmission of Nosema. So if you actually want to see if you have Nosema, you have to look under a microscope. There's no other way. This is the kit. This is all on my website. The easiest way I found is do the Ziploc crush. You take about 25 bees, you put them in a Ziploc bag, dry it with no liquid at all. You take a round quart jar, bigger than the diameter that you usually do is to crush them. You roll it over, it makes a very satisfying crunching noise. Crush them and you see all their guts come out. Then you add as many milliliters of water as there are bees. So there's 1 milliliter per bee. So if there's 5 bees, you put in a teaspoon of water. That's 5 milliliters. So 25 bees would be 5 teaspoons of water. Then you knead them to homogenize the gut contents with the water. You take one drop immediately of that homogenate because the spores start dropping quickly. So as soon as you mix it up, take a drop of that homogenate, put it on a slide underneath the cover slip, and look underneath the scope. There's 3 different ways of looking at it, of looking for a nosema. One is to put it under a hemocytometer. This is a blood counting chamber where you actually count the number of spores you see in a certain number of these cells, and then you plug it into a mathematical formula, and that tells you what your average spore count per bee is. I don't recommend this unless you're collecting scientific data. It's kind of tedious. The other one is the field of view. I did plenty of experiments looking at for the California State beekeepers to see how the field of view correlated with the Nosema spore counts. And what it works out to be in one field of view at 400x, for every 5 spores you can count, that's roughly 1 million spores per bee. So if you saw 5 spores in the whole field of view, your bees are running at about 1 million spores per bee. It's something like this where you're seeing about 30, that'd be about 6 million spores per bee. So now you've kind of quantified your Nosema level. But that's actually kind of an arbitrary thing, because when you take a sample of 25 bees, you don't know whether one bee has 500 million spores in it and all the rest were completely healthy, or whether all the bees had a certain number of spores. So to me, a more biologically relevant way of looking at it is to do what the original research was done back in 1920s, was you take 10 individual bees, you squash them, and you look at their guts, and you see yes or no, are they infected? And it generally is black or white. Either they're just totally infected or they have none. If only about less than 2 bees out of 10 are infected, it's usually not a problem for the colony. If you get about 4 bees out of 10, 40% of the bees in the colony are infected, you start to see a detrimental effect. Over 6 bees out of 10 infected, you start to see the colony go downhill. And over 8 bees out of 10 infected, you see sudden colony depopulation. Okay, so this is very biologically relevant. When I have taken samples and compared the two, I've compared gut squashes to spore counts for colonies over time. They track fairly close, but this was actually the more biologically relevant. So the question then is, do you treat for Nosema? I'll tell you the short version right now. In California, I have not seen a benefit from treating for Nosema, but we have a fairly short winter where the bees can get cleansing flights. So I'm not going to apply that at all for a winter where they are in there. It may be worthwhile. Dr. Medhat Nasser up in Alberta has brought colony loss rates way down. Canada last season is running, I think about, 14 or 15% colony loss rate, way better than the US, even though they have a much more severe winter. Alberta's rate is way down there. They're being very successful, despite almost all their colonies foraging on neonicotinoid treated canola. They do just fine up there because they control Nosema and they control Varroa mite. Okay, if you do those 2 things up there, they do very well. So the question is, what spore count should I be worried about? Fumagillin is a relatively dangerous chemical. It has a fairly high toxicity and lots of questions about it. It's rough on the bees. I would not put it in a hive unless there was a reason to do it. So the question is, what would I be worried about? So here's some data from me. I took 34 colonies and I tracked them for both gut squashes and spore counts from late summer all the way. Actually, I did it for a whole year, but I'm going to show you the late summer, the fall through spring counts. So what I'm plotting here is the scattergram for the millions of spores midwinter. I did a midwinter counts on December 20th. And then this is the percent of the strength in September to the strength measured in January. So this would be your winter decline of the colony. If there was a relationship between the Nosema spore count as it goes up and the winter decline, all these dots would be in a straight line and they would all go like that. The dots are not in a straight line. They don't go like that. The regression has virtually no correlation, which is indicating that there wasn't any relationship between the decline in my colonies and the midwinter, the December 20th spore count. How about the prevalence, the number of bees squashed, infected out of 10? Here's the data for the same period of time, September to January. This is the number of bees squashed at end. So this was eight bees out of 10 were infected December 20th. This would be 1 bee out of 10 infected. And you can see there's a somewhat of a correlation. So yes, Nosema did have a toll on it, but it was not a very clear correlation, very little overall relationship until Nosema got up to a very, very high level. And you can see when you get up to above 5 bees out of 10 being infected, yes, the colonies definitely did crash only at 10% of their strength midwinter that they started with in September. Does that make sense to you? You following these? Okay. So this tells me there really wouldn't be a reason for me to treat in the fall. Now, how about spring buildup? I want my colonies to build up now from January till I move them to almonds. So let's look at the difference, change in strength now from the January grading until the March grading. Oh, and this is typical winter. Before our drought, this would be typical winter where I live. This is my home yard right here. We don't see this much snow the last few years. Okay, now we're going January to March buildup, and this would be your percent increase in strength. So if a colony was 4 times as large in March as it was in January, they would be up to here, 400% increase. And what you can see here is, yeah, there was a little bit of a trend. They didn't build up quite as fast if they had high spore counts. Now look at these spore counts though. This is 20 million spores per bee. This is 40 million spores per bee. Most of them ran around this 5 to 10 million spores per bee. So yeah, when they got way up here to these really high spore counts, yeah, they did not build up quite as well. But this is not a treating when you see 1 million spores per bee, which a lot of people are recommending, okay? At the 1 million level, the colonies tended to do just fine. This is your number of bees infected out of 10 in December. And what you can see is, yeah, this one right here, which had 6 out of 10 infected, it just crashed. It was down to a fraction of its strength. But at these low levels, they seem to build up kind of randomly. So from this data set, I couldn't justify treating my colonies for Nosema. What we have found is, the question is, oh, I didn't put the data in there. I also looked at tracked spore counts and prevalence versus temperature. And what happens is, as the temperature went down, Nosema counts went up. As temperature went back up in the spring, Nosema counts went down. Just completely followed temperature beautifully. But then you often would get a spike of Nosema counts in the spring. And that was really a mystery to people studying Nosema ceranae, the invasion. Why would we get these springtime counts of high Nosema levels when we would expect it to be going down because it's getting warmer? And then subsequent research found out, wow, when the bees are getting a whole lot of pollen, their immune system is ramped up and they can let Nosema build to a really high level in their bodies without them getting sick. You put them in a cage and they're well fed, they can get a ton of Nosema ceranae in their body and they live just as long as control bees. Okay? So when pollen counts go way up in the spring, yeah, you're going to see scary high Nosema spore counts, but the bees are going to do just fine. During the initial invasion of CCD, when I started working with Nosema ceranae in 2006, I would go out and I'd collect swarms that started with spore counts of 5 to 10 million spores per bee, stick them in nuke boxes, get some sugar syrup, and they would just build up like crazy, build up beautifully, just as well as the colonies with no Nosema whatsoever. So even though Nosema ceranae was a huge scare for us for a while, I'm just not seeing that much more. It typically completely disappears during the summer. I can't even find it in colonies. It's a cold weather disease. As the colonies get chilled, the bees age in the colonies, you tend to get more Nosema. In the springtime, it tends to purge. Unless there's a lot of pollen coming in, then you get high spore counts. And during summer, it typically disappears. Now, in the Midwest, it doesn't follow that pattern necessarily. There are still spikes of really high Nosema spore counts in the middle of summer. And I haven't heard any explanation for why that is. I don't know whether it's because they're getting a good pollen flow and that allows it to go up or what. So right now, anybody who gives you a firm recommendation on when to treat for Nosema, how important is it to treat for Nosema, is just talking out of their ass. There is no scientific basis for anybody to make any kind of recommendation on Nosema ceranae because nobody knows. I can guarantee you that. I will tell you that Nosema ceranae infection along with a virus infection, you will often see a colony quickly spiral into collapse. But just Nosema ceranae alone, bees seem to be able to tolerate it pretty well. Also, as I mentioned, the initial wave of invasion, as Megan was saying, is tough when a new parasite comes into host. We seem to have passed that now. The only bees left alive. In fact, during CCD, we had somebody on lots of discussions on CCD on BLS. Aaron remembers. And one of our more prominent posters said, "Is anybody breeding for bees that are resistant to CCD?" I said, "Well, actually, I don't know any queen breeders at all who ever breed from dead colonies." So yes, if you're breeding queens, you're not going to breed from your sick or your dead colonies. So yes, by default, you are, or by extension, you are breeding for resistance to everything. And that's what's happened with Nosema ceranae. One of the things, and Megan was talking about, hygiene in operations. And yeah, I used to be really a stickler for hygiene. Then I realized I'm breeding bees. Do I want to breed bees that need constant babying, or do I want to breed tough bees? I said, you know what, I want to breed tough bees. So we just take all of our dead outs, we just stack them on. If they can't make it, screw them. Put that box in somebody else. We're going to breed for bees that can handle most problems by themselves so that we don't have to resort to medication. So we practice, if we have American foulbrood, really good hygiene. And the other disease-causing organisms, we're a little bit more lax about that. Yeah?
What about that research that was done by that one professor in Michigan that showed hyperproliferation when you treat with fumigillin?
Yeah, that's Dr. Lee Salter. We discussed that, Lee and I discussed that quite a bit. Her data, and I looked at the data, it looks good. And yeah, that is a question, whether her data is extremely sound. I've gone over her data very, very well. Yeah. So it certainly indicated that at low levels of fumigillin, it may cause hyperproliferation. That's, again, another reason why I decided not to use fumigillin. Okay? Okay, I wanted to get Nosema out of the way because our number one problem is Varroa. Any remaining questions on any disease or any pathogen or parasite other than Nosema? Other than Varroa? Oh, if you want to get really high spore counts, collect them foragers. Okay, but that's really misleading because that's your oldest bees that will always have the highest spore counts. We had a problem with this because different researchers were collecting bees from different areas. Kind of the scientific community standardized a collection from bees inside the under the cover or from an outside frame. Then you get a mixture of younger bees and older bees. It's a more representative sample. But if you sample a colony from bees from the brood nest and bees from the entrance, the ones from the entrance are going to have much higher spore counts than the bees from the inside. And so what I prefer, the most biologically relevant sampling is to take 10 bees from a mixed population from just inside the colony, outside of the cluster, and crush them one at a time. That pretty much tells you what the overall biologic impact of that infection is. Yeah?
In the single crush method, slide preparation, you crush one bee, 5 milliliters of water?
No. Just you crush it out, smash the gut out. I use a round-ended table knife. You leave a little bit of that material on the slide, add just a little tiny droplet of water, just enough to make it clear enough that you can see through it. Put a cover slip on there and give it a view. I actually cut 5 plastic cover slips up so I can do 5 at a time on one slide. It's very, very quick. We can crush 10 bees in the same amount of time it does to do one hemocent helminth count. Okay, so with practice you can do it very, very quickly. Okay, but I'll tell you right now, I haven't done a crush bee or a hemocent count in some time. What we do now is when we suspect a hive, when I see a bunch of dead bees, when people send me samples, and people send me samples regularly, I just do the quick, I count how many number of bees are in the Ziploc bag, crush them, add that many milliliters of water, look under the scope, and then you grade it this. No Nosema, a little bit, a fair amount, or oh shit, okay? You don't have to count anything. I mean, it's just a glance at that. So before you do the individual gut squashes, first do a Ziploc because it's really fast. If you don't see any Nosema, there's no reason to waste your time doing individual gut squashes because there's not going to be any Nosema. So first see if it's present at all. That's very quick. You can even do an apiary sample. You can just go around and take a few bees from a dozen hives in your apiary, do a quick Ziploc crush and look. If you don't see any Nosema spores, end of story. You don't have to do anything else. If you do see Nosema spores at a fairly high level, then you can start looking back at your colonies and seeing just how bad it is. Does that make sense? Yeah. Okay. As a commercial beekeeper, I want to minimize my work as much as possible. So I found the shortcut method of getting good, accurate data on everything. Yes, very good. Okay. You guys all know about Varroa life cycle, I would assume. Anybody here not understand the Varroa life cycle, roughly? Okay. One thing you should know is Varroa enters the cell of a larva at about day 8.5. That's the entry period. Drone larvae can be entered over about a 3-day period, worker larvae over about a 1-day period. And then when it's capped over, the cell's capped over, then the mother mite starts laying eggs. Typically gets a little better than one successful daughter per generation. So the reproductive cycle is 12 days in the cap brood, and then the mother mite is, and the daughters are phoretic. They are hitchhiking for anywhere from 0 days up to, could take a long time, but typically around 5 days or so in the phoretic phase. So a Varroa life cycle typically takes about 17 days when the colony is actively rearing brood, as opposed to 21 days for a bee life cycle. The problem with Varroa is most of the time you're not going to see them because they're in the brood. You're not going to see them in your hive. So you guys, if you follow my writing at all, you've all seen this graph. I'm going to return to this graph in just a minute, looking at the brood, the amount of brood that's in a hive, and how Varroa impacts the amount of brood that's in the hive. What it is Varroa becomes a problem in the late summer, and you just asked the question about how do you define fall. Fall is as the colony is tapering down its population in the late summer as the seasons changed, and then winter starts at the moment when you get your first killing frost or when there's no more pollen coming in, and then the bees go into winter condition. So this is your Varroa population, slowly builds up, peaks typically around September or so, and then it starts to drop down because there's less brood in the colony. But your alcohol wash or your powdered sugar shake or even sticky board counts will typically go up rapidly at this time because of the fewer bees relative to the number of Varroa mites. Okay, back to that initial graph. This would be your total pupae in the hive over the course of a season. Here's your total Varroa. Here's your percent of parasitized pupae. This is what you want to understand. Notice that early in the season, only a tiny percent of the pupae are parasitized. Virtually all the pupae get off with a free ride with no Varroa in them at all. As the colony starts to reduce the number of pupae, at this point, you've got about equal amounts of parasitized and non-parasitized pupae. Half of the worker bees being recruited are going to be parasitized by Varroa and infected with viruses, half of them. And as this gets closer to here, as they're restricting brood, so there's less brood and more mites relative to that brood, you're going to wind up with 3/4 of your pupae or more being infected with Varroa. So the impact of Varroa on the colony is very, very low during the buildup phase of the colony and very, very high on this late summer, fall decline phase in the colony. If you can grasp that concept right there, you can really grasp the importance of controlling Varroa at what time of the year. Everybody clear on this one here? It really has to do with what percentage of your pupae are infested by Varroa. Very low in the spring, very high in the late summer and fall. The point here is Varroa is not the direct problem. The deformed wing virus and the paralytic viruses are the main problems. There's only a few of the viruses that are actually transmitted by Varroa. And the main ones are deformed wing and paralytic. Again, I'll show you the picture of the beginning of deformed wing virus epidemic. This is typical of beekeepers who say, oh man, wax moths kill my colony, or neonics, or UFOs, or whatever, when they bring me their dead hives. I say, let me see a brood frame out of the box. And you tip it up, and you look for the telltale signs of the fecal deposits and the bees that are unable to emerge. It was a Varroa dead. Most common cause of colony losses. Another good picture of the fecal deposits of infected cells. So with Varroa management, what you're doing is vector management. I'm working right now with a biotech firm. We're working on a Zika virus. We're breeding, we have a sterile male release program we have going right now in Brazil using RNA interference. And with the Zika virus, with malaria, you don't deal with the Zika virus or malaria directly. You deal with the vector. If you can just remove the vector, then the disease is not a problem. The bacteria is not, or the virus is not a problem. Or what is malaria? What's the organism? It's a what? The plasmodium is not a problem anymore if you just deal with the vector. So when you're dealing with Varroa, you're dealing with vector management, okay? Oh, here's another rule for you. I did this also for the treatment-free beekeepers. This is the written rules for organic beekeeping. If you want to sell your honey, ask organic honey. So if you want to be organic, you cannot allow Varroa to take over your colony. It's against organic certification. And this one, I put this slide in particularly for the Marin County beekeepers. This puppy is suffering from a mite infestation. It's called sarcoptic mange. It causes the hair to fall out. And if somebody was walking down the street dragging this poor little puppy along with a t-shirt that says, "I'm a treatment-free puppy keeper," really proudly, what would happen to that person? PETA would be after him. They'd be burned at the stake. They'd go to jail. Being a treatment-free puppy keeper and being a treatment-free beekeeper both require a responsibility of not allowing your animals to get sick from a mite infestation. Okay, so you're starting out. You want to get a package of bees. When I looked at the actual figures, Dave Tarpey did some looking at East Coast bee packages, looking at the mite level in packages when you buy them. They was getting up to 5 mites per 100 bees in packages. I'll tell you right now, this is your best deal. At 5 mites per 100 bees in a 3-pound package, you're buying 600 mites. It only costs you 20 cents a mite. By far your best deal. Okay? Bees come for free, 20 cents a mite. Now, if you start that package at this mite level, and these are fairly, here's the numbers. Even a mite level 1 mite per 100 bee, that's 120 mites in a 3-pound package. At 5, it's 600 mites. So let's put some of these numbers in. Let's start at 50 mites here, and we'll start at 500 mites there. And this would be your mite level in the fall. If you're above 1,000 mites in the fall, your colony's not going to make it to the winter most likely, which means that even starting out with clean packages in your first year, you're unlikely to make it out unless you clean up those mites. It's very easy to clean up those mites in the first 8 days after you install the package. Before the first larvae are old enough for a mite to invade, just give them an oxalic acid dribble, put in an apivar strip, even a few really heavy powdered sugar dustings. Any of those things will drop most of the mites out and give you a clean start and buy you a lot more time. Okay, monitoring. If you're not monitoring mites, I call that blind beekeeping. Okay, and you will be surprised. You can use sticky boards. Sticky boards, especially if you're over 40, are really difficult to count and just tedious as hell. We pulled out sticky boards 2 days ago because I'm doing some new mite treatments, and I wanted to see what the actual increase in mite drop was per day. And when I pulled out my old sticky boards and greased them up, stuck them in, I go, and we did my first count, 120 mites, and I'm going, I remember why I hate sticky boards so much. The other thing is I compared daily mite counts on sticky boards to daily alcohol washes from the same hive over time, and they're all over the place. The alcohol washes track steady sticky board counts can vary by a factor of 3 every day. So I have no faith in sticky board counts. If you're doing them over a long period of time, they're a useful indicator, but they're not a very good assessment of your mite level. You have to do too many calculations to them. You have to do them relative to the amount of brood, relative to the amount of bees in the colony, relative to the time of the year, whereas alcohol wash gives you a very clean sample. So to perform an alcohol wash, I hope to do that, show you how tomorrow. Pat and I are going to go out to a store this afternoon and see if we can get the same kind of materials that I use for alcohol washes, which if you use the right materials, they're really fast and they're really easy. If you use different kinds of pans or cups or whatever, it makes them harder. So we have fine-tuned it because I do thousands of alcohol washes. We can do them very, very quickly and easy. First thing, you don't have to take a frame of a brood frame. You don't have to have a frame with brood on it to do the alcohol wash. The reason that all the books say do your alcohol wash from a brood frame is that the Varroa mite prefers to ride on nurse bees rather than older bees. Okay? Now, nurse bees, yes, they are on brood frames, but nurse bees also have to eat. And what do they eat? They eat a lot of bee bread. So all you really need to find is a frame that has bee bread on it. So out of your second brood chamber, look to see where the brood nest is and go in, usually about the third or fourth frame in, next to the brood nest. You pull out a frame, and it will have pollen, bee bread all over one side. And that guaranteed, that's where the nurse bees are going to be, because that's where the nurse bees go to eat, okay? Then you shake those bees into a tub, and you wait for just a few seconds, and the bees do this magic thing for you. You got to say the magic words. You ready? You say, "Old bees, fly off." Everybody say that. Old bees, fly off. Good. And it's magic. They will. You have to say those words, though, okay? You can say them to yourself so people don't think you're crazy. Shake them in there, and bingo, you just watch all the old bees fly off. If all the old bees flies off, what's left in the tub? Nurse bees, okay? So there's no reason to risk shaking your queen in there by taking a brood frame, because you can get all nurse bees just by doing that method, okay? Also, these bees will immediately spread out to a single layer like this, and the queen will stand out like a sore thumb if you inadvertently got her in there. Then we take I use a Rubbermaid brand dishwashing tub. The reason is, of all the dishwashing tubs I looked at, only Rubbermaid makes the right curve in the bottom of the tub that exactly fits a half-cup stainless steel measuring cup. And then I buy a half-cup stainless steel measuring cup, and I shake all the bees down to one side, put the cup there, and I tip the tub up and let them fall into the cup. Rather than scooping them, which then will crush bees, you let them fall into the cup. Then you pick it up, you take your finger, and just level them off. You can do that all day long, and you will never, ever get stung. Ever. Okay? Then you put them in a jar of alcohol. So we use wide mouth half-pint jars labeled on the top, because we take usually dozens of alcohol washes. Then we take them back and we do bulk washing on I have a washer tray. But out in the field, you can use a Mite wash cup. The Mite wash cups that involve shaking the bees up and down, you will recover about 85% of your mites. About 15% of them after your last shake will get caught in the bees as the liquid filters through the bees. So you do not get an accurate mite count. If you use a method like what I have on my website, we're using a cup where you swirl it instead, and the mites just drop straight down, you get 100% recovery of the mites. You get virtually all of them in the first 15 seconds. Works tremendously better. I've tested all the cups, all the wash methods out there, and this is by far the quickest and most accurate. If you're going to go through a lot of work, you might as well get accurate data out of it. This one is really simple, and plans for this on the website. Piece of tulle fabric and 2 clear cups. You can go down to, those of you, if you have money to burn, go to Starbucks and buy some drinks. The clear plastic cups work just fine. You don't have to do any kind of gluing or welding. Just stick that tulle fabric in there, and then when you lift out the tulle fabric, you'll have just the mites left in the bottom cup right there. And we're going to have to find something like that tonight. But anybody have a source for what's that? Okay, does anybody have it at home they can just bring to save us from going to Joanne's? Any of you guys? Back a little ballerina dress in the closet somewhere?
Hours to see you. Our homes are hours away.
Hours away, okay. Okay, we're going to go shop at Joanne's. Yeah.
Shopping, just a sponge, they sell it in any store. Just a sponge made from tulle.
Really? Oh, wow.
It works just perfect.
Oh, perfect. Okay, I'll look for that. Thank you. Okay, and then when you look at the bottom, you count your number of mites. If you put a half cup of bees in there, that's roughly 300 bees. That means for a 1 mite per 100 would give you 3 mites. 2 mites per 100 would give you 6 mites. Okay, you understand the math on that? Okay, so what's that? Yeah, treat this. Yes, this one would be just about time to start thinking about treating. If we get, as we are sampling our bees right now, as we approach this time of year, as we approach the 6 mites per alcohol wash, we get on it. So I got the report back from Eric and Ian. They've been calling me every day. We're running typically 3 to 5 mites per alcohol wash. We got a couple of colonies that are hitting about 10 mites. So yes, we'll be getting on treatment seriously next week. Okay? So we have already treated our hives and split them twice so far this year. So that's how accurately we are tracking our hives. We know, I can tell you anytime exactly what our alcohol washes are across our operation.
Are you sampling each hive in each yard?
No. We have 1,500 hives. We have almost 50 yards.
How big of a sample do you take?
So what we sample is typically 2 to 3 hives per yard, and we're sampling every day. Okay, we just carry the kit with us all the time. So we always have an idea. So it's not like we go out once in a great while and sample 1,500 hives. We're sampling a proportion of our hives on a constant basis, so we know where our mite levels are at.
Then you treat the entire yard?
We entreat the entire operation at the same time because we're doing selective breeding, which means we want to compare apples to apples. If we only treated a few hives, we couldn't compare whether that is a breeder queen or not because some colony might have gotten preferential treatment. So we treat the whole operation at the same time.
And you don't keep a yard with untreated bees?
Actually, I'm keeping 3 yards right now with untreated bees because I need high mite levels to do experimentation on mite treatments in order to get a high enough mite count that I can get good data on that.
What will you treat with?
Hang on, you're getting ahead of me. But that's a very good question.
Well, why is it so important to test? If you've been doing this for years now, you kind of know when they're going to be exploding, the mites.
You kind of know.
But how important is it to test? If you know you're going to be
We'll get to
treating-
that.
Okay.
That's a very good question too.
Okay.
Okay, you can also do the sugar shake if you're just totally adverse to killing 300 bees. If you have a very strong arm, I suggest using a plastic bottle rather than a glass bottle because you're going to get a tennis elbow or something trying to do this. And it's really rough on the bees. It beats them up. In warm weather, it can kill some of these bees, but you can dump them out and they will walk back in gently. Not always. I did this demonstration. We did a demonstration 3 weeks ago in the Bay Area, and I did the alcohol wash and I did a powdered sugar shake, and we got God, what we got? We got like 3 mites in the powdered sugar shake. We got 14 in the alcohol wash from the same hive, and half the bees in the powdered sugar shake died anyway in front of the hive. It was pretty pathetic. A whole bunch of people who were really big on the sugar shake changed their mind that day when they saw the comparison. Yeah.
It's always kind of interesting to, if you do a sugar shake, do an alcohol wash
Afterwards.
You'd be surprised on what's left.
Yeah, typically when I have done that, we typically get about 70% recovery on the sugar shake compared to the alcohol wash. I look for a good picture. I also, as Megan does, I like looking for Google images, although I gotta admit, I have never searched for pictures of dogs driving tractors. You have expanded my horizons, Megan. No, I'm gonna have to email you and find out what other cool things you search for images of. You must have more time on your hands than I do, but I guarantee you I'll be looking. We can compare pictures, okay? Okay, and pretty soon it'll be goats manning drone aircraft or something. Anyway, this is the picture that epitomizes the look I see on all these beekeepers' faces that come to me that spend all the hard-earned money on buying nukes from me, and they come back and Varroa's killed them. They look like this. Okay, danger zone. Number of mites per 100 bees is about 200. 2 mites per 100 bees. That'd be 6 mites in an alcohol wash. You can get up, depending on the time of season. September, we'll let that creep up. So instead of ours, if we get up to 8 to 10 mites in a half cup alcohol wash in September, in some proportion of colonies, we're not that worried, as long as the brood is looking good and clean. But the rest of the year we want it low. Now, that doesn't mean we're happy with that level the entire year. We want to have 0s to 1s early in the season because you know that the mite level is roughly going to double once every month, okay? So we want to make sure it's low before we put our honey supers on, and then we check while the honey supers are on, and then as soon as we get the honey supers off, we want to check and see if we got to do a mite knockback at that time. When you're doing your alcohol wash, again, realize you're just washing the adult bees. Most of the mites are in the brood. So if there's a lot of brood, you're going to have a lower proportion in the alcohol wash. If there's very little brood, you'll have a higher proportion. If you do an alcohol wash during the winter, there's no brood at all, there's no mites in the brood, so your alcohol wash will go way up in the wintertime. Question of when to monitor. We do it as soon as we get back from almonds, before we put the honey supers on. We've split and treated it this time with oxalic acid. We do a check while the supers are on, immediately afterwards, and then if we're in a yard where there's any unmanaged or poorly managed colonies around where we get a flooded immigration, out here we check a lot in the late summer. In answer to your question about times to do that, you've got to give me more information. How warm was your winter? If you have a mild winter, you better get on mites a whole lot earlier. If you have a long cold winter and there's no reproduction of mites during that long winter, you have some time before the mites are going to build up. So you got to look at a lot of factors. How big are your colonies? How rapidly are they building up? All those are factors. So I can't just give you a calendar time to check. You really need to do it relative. A few years ago, Ray Oliveris, the queen breeder, and I were talking. And he says, "Oh, Randy, it's going to be a disaster in almonds next year. There'll be a shortage of bees." I said, "Ray, it's 11 months in advance. How can you tell me that?" He goes, "Easy. We just had the warmest winter on record," which means that most of the beekeepers are not going to realize they're going to be starting the season with twice the mite level that they had normally, which means they're going to do their calendar treatment, and they're all going to be mystified by why all their colonies crashed in the fall, and there will be a shortage of bees in the almonds. And 11 months later, he called it, okay? So you have to look at a lot of factors. This is temperature deviations for California from 1880 until 2010, showing which years you had extra cold winters, which years you had warm winters. After this winter right here, Varroa is not going to be a problem for a while because there was no reproduction of Varroa for a long time. After this winter, this really warm winter, Varroa is going to be a big problem that spring. Is that clear?
What is the black line here?
Black line is normal. Black line is, this is deviations from normal. This is a winter colder than normal. This is a winter warmer than normal. Does that make sense? Okay. Deviations from the norm. That's another name for beekeeping, beekeepers. Deviations from the norm. Okay. You heard this, Marta Spivak's been talking about this herd immunity. Dennis Van Engeldorf's been talking about mite bombs. Of interest, they both decided this year apparently to stop worrying about being politically correct, and they're calling a spade, and they're telling the treatment-free beekeepers, clean up your act. It's been a long time coming to see the major speakers doing this. That way I don't have to take all the heat. Here's our alcohol washer right here. What I did is I've got a battery inverter, so I can now take the washer out in the field in the back of the pickup truck as fast as Eric and Ian can do alcohol wash shakes into these mason jars. I run out there, pick them up, and I can wash them, and we can go into a yard of 36 colonies, and in 45 minutes we can wash every single, get a count for every single colony in there if we want. So we can do it really fast now. I was looking for colonies with high mites last September because I wanted to do a trial of mite treatments. So I wanted to bring in colonies from all the various yards that had high mites, put them in all one yard, and then use them for a mite treatment trial. We had in order to get the 75 colonies, we had to go through 203 hives to find enough with high mite levels. So here's the histogram, the distribution of them. This says that when we checked in September, this is mid-September, the colonies with mite counts of 0 to 5. Out of those 203, we had about 110 hives. Very low mite levels. That's very good. That's just what we wanted. 6 to 10 mites. We had 40-some hives. And the interesting thing here is that we had these outliers, a few hives that were just mite bombs waiting to happen. Very high mites. So it was not a bell-shaped curve at all for mite levels. We have the vast majority of our hives, 75% of our hives, we had mites totally managed very well. 25% of our hives, mites were very high. Now, when I did the math of that, and I took the number of mites and multiplied the number of colonies, I found out that 75% of the entire mite population of my operation, of those 200 hives, were in only 25% of the hives. So 1/4 of the hives contained 3/4 of the mites of all of them. Those were the ones that are the problems right there. This is really an eye-opener to me, because when I did any kind of calculation of even minimal drifting or robbing in here, these 25% doubled the mite counts of the rest if I didn't treat those other ones. Doubled the mite counts easily. And this is what we see happening in the towards the end of the season, this mite immigration from hives outside. So I plotted this in with immigration levels. I went through all the data, anything published on actual mite counts of how fast mites come in the summer and fall into hives. And I put 4 levels in: immigration level of 0, 1, 2, or 3. This is a fairly high immigration level, but all measured actual data. So I'm going to show you, I'm going to change this from a 0 to a 1 to a 3 to a 4 in the next ones. And what I just want you to see is this is your alcohol wash, this is your total mite level in the hive. What happens? Watch what happens. I didn't change the reproductive rate at all. I'm only going to change the immigration in the late summer and fall. So to go up to a moderate or a low immigration, go up to a moderate immigration, go up to a high immigration. So we go from ending here with a mite level of about 1,500 mites. Now we're up to 1,700. Now we're up to over 3,000, and now we're off the scale. Didn't change anything other than just the immigration of mites coming in, all measured rates. Immigration can overwhelm everything else you do if you are surrounded by a bunch of negligent beekeepers who don't manage their Varroa levels. And that brings us to this point. And this is your job now, guys, to go out to your communities and make this point very, very clearly. Yeah? Say it again?
25% of the mites, do they have any overt signs?
Well, they will, and at that time you have to get up to alcohol washes around 50 before you start seeing typically signs of deformed wing virus in the brood. You have to get pretty high, okay? But that doesn't mean that it's easy to, that colony by that time is too hard to turn around that late in the season, okay? So no, you don't. And right now, I'm running about 200 hives. I'm trying to hold mite levels between about 30 and 50 in these hives. There's only a very few that show any kind of overt signs, okay? Even though they have sky-high mite levels. Here's a scary figure. That's from Dennis Van Engelsdorp. Okay, if you were in agriculture and you had an orchard or a crop and you were the only treatment-free orchardist, your other orchardists would slash the tires of your truck or something. You would be put out of business by peer pressure because you would ruin it for the rest of them. Your codling moths or your boll weevils or whatever you had would flood all the rest and make all their efforts at controlling pests in their orchards or their cropland moot. The same thing happens with beekeepers. If hives are at a widely spread out density, there's very little transmission of parasites between them. And if a colony collapses from Varroa, it's no big deal. If instead you live in a neighborhood where you have a whole bunch of recreational beekeepers, the parasite transmission from hive to hive is extremely high. This is the kind of stuff that Megan was talking about with transmission. If you're within, bees can travel up to about 5 miles. Then they run out of fuel, so they can't go any further than that. Most foraging is done within a couple of miles. The one experiment that got good data was done on an Air Force base by Eva Fry in Germany. They put some colonies ready to collapse in the middle of the Air Force base, and they put some hives to monitor mites immigration right next to them. like 10 meters away, 100 meters away, and 1,500 meters away, about a mile away. The mite immigration a mile away was the same as it was from the hive right next to it.